In today's note, we're going to be looking at a certain type of equation called the Pythagorean Theorem. Now, you may have seen this before in previous years, which is great, but we will be reviewing it again. So, what the Pythagorean Theorem is for, it is for finding a side length in a triangle. And over here to the right, in order to find or help us find the side length in a triangle, we need to know some specific sides. And the one main side is the hypotenuse, and the hypotenuse is the longest side of the triangle, or it is the side across from 90 degrees. Now, I would always recommend using across from 90 degrees as your definition. Not that it's wrong to say it's the longest side, but just because depending on how our triangle is laid out, it may not be as easy to find as it is across from 90 degrees. Well, across from 90 degrees is usually always the easiest one to find. And aside from that, we have our two legs, which would be the other two sides of our triangle. Now, this theorem only works for right triangles, and what we mean by right is 90 degrees. So this only works for 90-degree triangles or right-angled triangles. It doesn't work with other types of triangles. Now, the way this theorem works is if I have a triangle, and let's say one leg is 3 and the other leg is 4. If I take each leg and I make a square off of it, so in this case, the square would be 3 by 3 or 9. Let's color these in. And I do the same thing with my other leg, in this case 4, and I make a square off of it, so 4 by 4. Go through and color these in. I would have one square that has an area of 16, or 4 times 4, and another square that has an area of 9, or 3 by 3. And the idea is that with these squares, I can find the length, or the square, of my other side. So if I take all these squares and add them into this big one, so if we go around the edge here, so we have the 16, and if we go, we can fill all these squares in. So there are 16 squares, and we see how much is left over. Well, that happens to be exactly 9 squares. So that means that the two squares added together make the square of the longest side. And this side length happens to be 5, or a 5 by 5 squared, which is 25, or you could think of as 19 plus, or sorry, not 19. 16 plus 9 adds up to 25. So that's where the theorem a squared plus b squared equals c squared comes into play. We take 1 squared, or a side length times itself, plus another squared, or side length times itself, and it equals the largest square, or the hypotenuse, times itself. So what does each letter in this formula mean? Well, A and B represent legs, and then C represents the hypotenuse. So if we look at one example here, I have my 2 legs and I'm missing the hypotenuse. So what this means is that I can use my formula a squared plus b squared equals c squared. And here I'm going to just label my sides a, b, and again the hypotenuse is always c. So a and b can be interchanged. So in this case, A could be 17, B could be 10, or the way we have it right now. So I'm going to substitute those values in. So 10 squared plus 17 squared equals c squared. Remember that if I'm squaring, I'm multiplying the number by itself. So 10 squared is 100 plus 17 squared, which is 289, equals c squared. Now if I add these together, 389 equals c squared. And some people may think that they are finished. However, one thing that we have to be aware of is that I'm not looking for c squared. I'm trying to find c. Right? If you think back to my triangle and the squares, I don't want to know the area of that large square. I want to find the side length. So in order to do that, I have to take the square root of my answer. So I have to take the square root of 389, which works out to, so the square root of 389 is going to equal c, or you could think of it as the opposite of squaring something. And this, so the square root of 389 works out to 19.7, which equals c. So this is our final answer. And it makes sense because it is the longest side, or it is longer than our other two sides. Now, for example 2, I have my longest side, or 13. I have another leg, we'll call it B, and I'm looking for my other leg, which is X, or we'll call A. So if we start off with our Pythagorean theorem, a squared plus b squared equals c squared, I don't want to solve for c anymore. I want to solve for a. So in order to do that, I can rearrange this equation by subtracting b from both sides. And what happens is I get a new equation of a equals c squared minus b squared. And this is the formula that we use when we're trying to find a leg. And it makes sense because if you look at again at our triangle with the squares, our regular formula to find the hypotenuse, we're adding two small squares together. Our other way for finding a leg, I'm subtracting a small square from the large square. So it makes sense that when I'm trying to find a small one, I'm subtracting from the larger, and when I'm trying to find the big one, I'm adding two small ones. So in our rearranged formula, the a squared equals c squared minus b squared, I'm going to plug in my values. A squared I don't know, c squared is 13, or 13 squared, and I'm subtracting 8 squared. A squared equals 169 minus 64. So I get a squared equals 105. And now again, if I want to find the actual side length, I need to square that. So a equals the square root of 105, or a equals 10.2. And this is my final answer. So two other examples. If I want to find the length of the diagonal. So in this question, the dimensions of a monitor are 36 centimeters by 27 centimeters, and I want to determine the length of the diagonal of the monitor. So if I just draw a monitor here, say it's 36 by 27, and I want to know what is this diagonal. Well, because it's a rectangle, or you can think of it, a monitor as rectangle or square, I am going to know that then I have right angle triangles, or right angles in my corner. So this diagonal would split my rectangle into two triangles, or two right angle triangles specifically. So because it does that, I can use my Pythagorean theorem, a squared plus b squared equals c squared, with one leg being 36 and another leg being 27. So my formula is now 36 squared plus 27 squared equals c squared. 36 squared is 1,296 plus 27 squared, which is 729, and all of that equals c squared. So I want to add these two together, and they get 2,025 equals c squared. Again, c squared is not my final answer. C is, so I need to find the square root of 2,025. So the square root of 2,025 will equal c, and this works out to 45.3, which equals c. So this is my final answer. Another thing we can do using the Pythagorean theorem is figure out if a triangle is a right angle based on the side lengths. So if I have the side lengths of 8, 10, and 16, and I wanted to draw a right angle triangle, my two legs would have to be 8 and 10, and the hypotenuse would have to be 16. This is because, again, we know the definition for the hypotenuse is that it is the longest side. So that longest side would have to be 16. Now, just looking at it, we just drew a small version. We don't know if these measurements are actually right or if it actually makes a right angle triangle. But what we can do is use a squared plus b squared equals c squared to see if this equation works. So a squared, remember a and b are our legs, c is our hypotenuse. So we have 8 squared plus 10 squared equals 16 squared. 8 squared, 8 times 8 is 64, plus 10 times 10, which is 100, should equal 16 squared, which equals 256. Now at this point you may be able to see what's going to happen, which is fine, but if not, well, 64 plus 100 is 164, equals 256. Now we know that 164 and 256 are two different numbers, so this does not equal. So because they do not equal, that means this is not a right triangle. So no, it is not a right triangle. So this theorem works both ways. If the triangle is a right triangle, then we know that a squared plus b squared equals c squared. And if we try and find that a squared plus b squared equals c squared, and that works, then the triangle is a right triangle. So you can use this in two ways. One, to help you find missing sides, given the information that it is a right triangle, or given all the sides, you can check to see, is this a right angled triangle? So again, the main thing from this note is being able to correctly use the formula to find either hypotenuse or the legs and understand how this formula works.